Hey guys, welcome to Math for Kids by a Kid. Today we're going to talk about adding and subtracting radical expressions. So first let's start off a review of last video on mixed radicals and entire radicals. So I'm just going to show you quickly what a mixed radical is. So let's say we have the square root of 27. This is a non-perfect square, but we can simplify it further. We find the hidden square factors that are in 27. So if we were to draw a tree diagram, 27 is 9 times 3, and 9 is 3 times 3. We have 9 as the hidden perfect square factor. So this is the same as the square root of 9 times 3. And then from here, the square root of 9 is 3 times the square root of 3. And this is a mixed radical. So in this video, I'm going to talk about like radicals. And I'll show you what that is right now. So let's say we have these mixed radicals. 3 times the square root of 3, 2 times the square root of 6, 5 times the square root of 10, 5 times the square root of 3, and 4 times the square root of 6. And let's say we were to group these into sets of like radicals. So this is actually very simple to figure out. You simply have to see which of these mixed radicals has the same radicand. So 3 times the square root of 3 and 5 times the square root of 3 have the same radicand for the radical part, and that's 3. So 3 times the square root of 3 and 5 times the square root of 3 are like radicals. Now let's look at the rest. We have 2 times the square root of 6, 5 times the square root of 10, and 4 times the square root of 6. 2 times the square root of 6 and 4 times the square root of 6 have the same radicand for the radical part, and that's 6. So these two are like radicals. And then 5 times the square root of 10 is just by itself. Now, an important thing I want to point out is that these mixed radicals have the same root for the radicand. So these are all square roots. The reason why I'm bringing this up is because if you had 3 times the square root of 3 and 5 times the cube root of 3, these are not like terms because one is the square root and the other is a cube root. So they have to have the same root in order for them to be like terms. So now that you know what like radicals are, let's practice. So let's say we have to simplify 3 times the square root of 2 plus 2 times the square root of 2 minus 5 times the square root of 2. So first of all, we should notice that these are all like radicals because they're all square roots and they all have 2 as their radicand. And when we have this, all we have to do is add the coefficients. So 3 plus 2 minus 5 is 5 minus 5. I'll just write it out on the side. This is 5 minus 5, which equals 0. And so this would just be 0 times the square root of 2, which just equals 0. Now let's look at this example. The cube root of 16 plus the cube root of 375 minus 3 times the cube root of 2. So what's different here is that they are all cube roots and they're not completely simplified. So what I'm saying by that is these two here, these two terms, they can be written as mixed radicals. And we need to write them as mixed radicals so that way we can see which terms are like. So let's start with the cube root of 16. We're going to find the hidden cube root factors. This is 8 times 2, and we know that 2 times 2 times 2 is 8. So the cube root of 16 is the same as the cube root of 8 times 2, which is 2 times the cube root of 2. Now let's start with the cube root of 375. That is 3 times 125. And we know that 5 times 5 times 5 is 125. So this is equivalent to 125 times 3. From here, this is 5 times the cube root of 3. So now let's use these simplified terms and rewrite the equation. So it now becomes 2 times the cube root of 2 plus 5 times the cube root of 3 minus 3 times the cube root of 2. And this looks much simpler now, and we can solve from here. So these are all cube roots, so that's taken care of. Now we just have to look at the radicands. 2 times the cube root of 2 and negative 3 times the cube root of 2 both have 2 as their radicand. So we just have to add 2 and negative 3, which is negative 1. So we get negative cube root of 2. We don't have to write the 1. It's invisible, but it's still there. Plus 5 times the cube root of 3. And this is the final answer. Let's look at this example. We have the square root of 4a plus the square root of 16a minus the square root of 9a. So the square root of 4 is 2. That gets rid of the 4. And then we have a left over. So it's 2 times the square root of a. The square root of 16 is 4. Then we have a left over. So it's plus 4 times the square root of a. And then 9 square rooted is 3. And we have a left over. So it's 3 times the square root of a. And we have a minus here, so we just write that here. And from here we add the coefficients. So 2 plus 4 minus 3 equals 3. So the final answer is 3 times the square root of a.